So welcome to Everyday Mathematics. Now today we are still on the 2021 University of Florida Integration B qualifying round. We move forward to part 2 where we look at problems 7 and 8. Problem 7 is the indefinite integral of x to the power 21 times e to the power x. Problem 8 is the definite integral from x equals to 2 to x equals to 4 of the square root of the natural logarithm of 9 minus x all over the square root of natural logarithm of 9 minus x plus the square root of natural logarithm of x plus 3. So these are very interesting problems. I would like to just keep it succinct and short as we are proposing here. If you haven't subscribed to our channel, we do encourage you to consider subscribing to my channel. If you do have any questions in the course of our solution and our proposing, please don't hesitate to reach out to us. Here at Everyday Mathematics, we do enjoy solving these harder problems, and we do also like to share them with you. So without much ado, we are moving forward to the solution phase of the video. So on to problem number 7, the indefinite integral of x to the 21 times e to the x. So what we're going to do here is we could re-express this problem as the integral of the product of x to the 21 times the derivative of e to the x. So what happens is that the derivative of e to the x is the same as e to the x. And so we can now go ahead and use integration by parts, where if you have a product, the integral of a product of a function u and the derivative of function v, that's the same as the product of u and v minus the integral of the product of function v and the derivative of the function u. So here, what we see here is our function v is e to the x, our function u is e to the x to the 21. So the product uv is the same as x to the 21 times v, which is e to the x, minus the product integral of the product of e to the x times the derivative of x to the 21, where obviously the function u is x to the 21. So we have x to the 21 times e to the power x, and now the derivative of x to the 21 is 21 times e to the power 20. So, and we repeat this same problem because now we do have an integral that is very similar to our original integral, only that x to the 20 is what we are having here. So let's color code this as blue, and what means is that we could bring out this same solution but staggering down to 20 instead of 21 here. So we have 21 times x to the power 20 instead of x to the power 21 here, times e to the x minus 20 instead of 21 here, times the integral of x to the power 19 times e to the power x. And so we can repeat this same process. Since we have this, we can now repeat that same process by now color coding this x to the power 19 times e to the power x integrated with green. So if we repeat that same process, we continue going down, and this 19 now would become 18 in the next integral here. So this process can be repeated. We can, and that is called iteration. So we can iterate all the way down to when we have 0 here. That is x to the power 0, which is 1. So that's a very interesting step to undertake, because now we have then if you follow, the plus and minus keeps alternating, and when it comes all the way to 21 factorial down here, we're going to have a minus. So 21 factorial times the integral of x to the 0, which is 1, times e to the x. And when we solve that, we have x to the power 21 times e to the power x minus 21 times x to the power 20 times e to the power x plus 21 times 20 times x to the power 19 times x to the power e to the power x minus 21 times 20 times 19 to the power x to the power 18 times e to the power x all the way to minus 21 factorial times e to the power x plus integration constant. We can succinctly express this, the solution that we've obtained here, as e to the power x, because we can pull that out, times the summation from k equals to 0 to k equals 21 of 21 factorial over 21 minus k factorial times negative 1 to the power k times x to the power k plus the integration constant. And this here, ladies and gentlemen, is our solution. So it just requires patience and being a little bit attentive to the detail. If you have any questions, please don't hesitate to reach to us. If there is a mistake that we've made, please, we will be very happy to hear from you. So let's move forward to the next problem. So on to problem number 8. The definite integral from x equals to 2 to x equals to 4 of the square root of natural logarithm of 9 minus x over the square root of natural logarithm of 9 minus x plus the square root of natural logarithm of x plus 3. So this obviously is a tricky problem. One may be tempted to try and do substitution, but I think what they're trying to look here is symmetry in the sense that this natural logarithm, square root natural logarithm of x plus 3 being in the numerator here within this interval should be the same as this integral. So how do we show that? Let's begin by saying I equals to our integral here. And what I could do, I could say this natural logarithm of 9 minus x is the same as a natural logarithm of 3 plus 6 minus x. And so the same thing would happen here, but natural logarithm of x plus 3 is the same as 9 minus 6 minus x. Okay, so what happens? If now we focus on the 6 minus x here, and we try to substitute for 6 minus x, right? What happens? So let's say let u be equals to 6 minus x. So what that means is the derivative of u with respect to x is equal to negative 1. And so we can substitute for dx with negative du. What about the limits? When x equals to 2, that means that u equals to 4. When x equals to 4, that means that u equals to 2. And that means that we can now express this integral in the u domain, where at the lower interval instead of 2 we have 4, the upper interval instead of 4 we have 2, and then instead of 6 minus x we have u, and also instead of dx we have negative du. The negative is here, and with such integrals, if we have a negative sign here appended to it, we can now flip the limits, and that sign disappears. So what happens here? It means that the same integral I is the same as our integral square root, integral from x equals to 2 to 4 of the square root of natural logarithm of 3 plus x over natural logarithm, square root of natural logarithm of 3 plus x plus the square root of natural logarithm of 9 minus x. So we have the same integral, only that the numerator now is the square root of natural logarithm of 3 plus x. So what that means is that our I is the same as the integral that we're given, but also it's the same as the same integral, the integrand with the same denominator, but the numerator being square root of natural logarithm of 3 plus x. Therefore, when we add I plus I is the same as this integral plus this integral. And then when we combine the numerators, since the denominators are the same, we come down to an expression where the numerator is the same as the denominator. Okay, so 2i is the same as the sum of the square root of natural logarithm of 9 minus x and the square root of natural logarithm of x plus 3, which is also the same as the denominator. And so numerator and denominator cancel out. And that means that 2i is the same as the integral of 1 from x equals to 2 to 4. And that means that our integration becomes x from 2 to 4, which is 2i being equal to 4 minus 2. And that means that 2i is equals to 2, and therefore I is equals to 1. This means that our original integral is equal to 1. And that was the answer that was expected of us. So very, very interesting problem. I hope you had an interesting session following along. If you have any question, please don't hesitate to reach out to us. If you do have any suggestion of alternative solutions, we welcome your suggestions as well. We'll be sure to make an extra video to share your thoughts. Until next time, bye-bye.